We have already seen that rational numbers are spread densely across the number line. Because of this, it appears that every single point on the line must correspond to some rational number. For centuries, mathematicians believed that every measurable length in the entire universe could be represented as a perfect ratio of two integers. However, around 800 BCE, an Indian mathematician named Baudhayana was writing the Sulba Sutra. While calculating complex geometrical layouts, he encountered something shocking: geometric lengths that completely refused to be written as a fraction. A few centuries later, the ancient Greeks stumbled into the exact same crisis. The famous Pythagorean school believed that all numbers in the universe were rational, but Hippasus, an early follower of Pythagoras, tried to calculate exact length of diagonal of a unit square. He realized that this diagonal could never be expressed as a fraction of two integers. What actually he's trying to do, he was trying to calculate the length of diagonal. For that, he used Pythagoras theorem, and he find out that this length cannot be written as a ratio of integers, and he actually proved it. So how do we define irrational numbers? Numbers that cannot be written as p over q with integers p and q where q not equals to 0. Here is some examples of irrational numbers: square root 2, square root 3, square root 5, cube root of 3. Note, the presence of radical symbol does not necessarily mean that the expression is an irrational number. In many cases, we can simplify the expression and eliminate the root symbol. Let's see some examples. Let's see square root 4. We can write it as square root of 2 times 2. Since it is a square root, we group them into pairs and take one out, which is exactly equals to 2. Since this is simplified and we completely eliminate the root symbol, so this is a rational number. Let's see one more example, square root 24. If we find its prime factors, we have 2 times 2 times 2 times 3. If we pair up first two 2's, we got 2 times square root 6. Because square root 6 cannot be simplified any further into a whole number, the radical symbol remains. Therefore, square root 24 is an irrational number. Let's see how do we plot irrational numbers on number line. We are going to do this the same way they were originally discovered, using geometry. We will build a right angle triangle with a right base and height to get our irrational value as hypotenuse. Let's first see how we plot the square root of 2. Our task is to construct a right angle triangle whose hypotenuse is exactly square root 2. To do that, we have to choose a base and a height. We know that from Pythagoras theorem, our hypotenuse is equals to square root of base square plus height square. So our perfect choice for base is 1 unit and 1 unit for height as well. So when we use height and base 1, then our hypotenuse is going to be square root 2. So let's plot. So we know that square root of 1 is equals to 1 and square root of 4 is equals to 2. So square root of 2 is going to be in between 1 and 2. So let's draw our number line. So this is our number line. We take our base from 0 to 1 unit, and write this point as A and this point as B. Now in order to construct a right angle triangle, we have to construct a right angle at the point B. So take your protractor and construct a 90-degree angle.
Here we have marked 90 degree and we draw a perpendicular at B. Now mark height 1 unit on the perpendicular line. To do that, we take our compass and measure 1 unit. Mark 1 unit on perpendicular line. Name this point as C. Here BC is 1 unit. Height is BC. We have already constructed AB, which is our base of 1 unit. Now we match point A and C, and this is our hypotenuse of length square root 2. So here we have our length square root 2, and we have to mark this length on this number line. So to do that, we measure this length and we mark root 2 on the number line. So this point D is representing our square root 2. Let's see how do we plot square root 3. Here too we have to choose right length for base and height of this right angled triangle so that our hypotenuse gives us root 3. So what is the right choice? Let's look at Pythagorean math. To get a hypotenuse of exactly root 3, we need a base of root 2 and a height of 1 unit. Think about it. Square root 2 square is equals to 2 and 1 square is 1, and these both add up and gives 3. So hypotenuse is equals to square root 2 to the square plus 1 to the square, which is equals to square root 2 plus 1, which is equals to square root of 3. So it is essential to first plot square root 2 on number line and use it as a base. This is our square root 2 which we have plotted earlier. So this is our base. AD is our base, which is square root 2. Now we have to plot height. For that we have to draw a perpendicular to the point D. So to do that, we take our protractor and mark 90 degree and we draw the perpendicular. Now we have to mark 1 unit on the perpendicular line. So to do that, we take our compass and measure 1 unit. So this is 1 unit. Now we take this 1 unit and mark this on the perpendicular line. So this point is our E. Now we construct our right angled triangle ADE. This length is square root 3. Since we have to mark this length on this number line, so we take the measure of square root 3 on our protractor and we mark this on the number line. So this point F is representing our square root 3. This is homework question for you. Question 1 is asking you, is square root 144 is rational or irrational? Question number 2 asking you, is square root 54 is rational or irrational? Write your answers in the comment section. And the question 3 is asking you to plot square root 5 on number line. Plot a square root 5 in your notebook and write your choice for height and base of a right angled triangle in the comment section.